Something strange might be happening with Comet 3I/Atlas.
Reports suggest NASA instruments could be seeing sudden, repeating events from this interstellar visitor.
If those observations hold up, they don't just show random flares, they could be revealing a pattern, a kind of hidden heartbeat across multiple wavelengths of light. And in that pattern may be the first real clue to how an interstellar comet behaves when it enters the furnace of our Sun for the very first time in billions of years. Today we're going to dive into what scientists call a burst fingerprint, how it might look in infrared, ultraviolet, X-ray and radio bands, and what that combined signal could tell us about 3I/Atlas.
This is not science fiction.
This is the genuine mystery of an ancient wanderer from another star being heated by our Sun for the first time in eons. Most comets we've studied are local. They've swung by our Sun many times, losing material and showing fairly predictable behavior.
But 3I/Atlas is different.
It's a true interstellar object, formed under a completely alien chemistry, drifting in deep space for perhaps 7 billion years before its first close pass to a living star. If it's producing outbursts now, that's our one and only chance to watch a pristine comet react to solar weather. And if those outbursts repeat in a pattern?
That's the fingerprint, a diagnostic tool.
Like detectives at a cosmic crime scene, astronomers can use the timing and strength of each burst across different wavelengths to deduce what's happening inside the nucleus, what gases are venting, and even how the comet rotates.
In the infrared, you're essentially looking at the comet's breath.
Trapped CO2 and CO deep inside the nucleus vent out and absorb specific infrared wavelengths. Instruments like the James Webb Space Telescope can detect these molecular signatures in exquisite detail. A sudden spike in CO2 absorption lines would tell us fresh ices are venting from deep within, something local comets rarely do this far from the Sun. One leading idea is that these potential bursts aren't spontaneous at all, but triggered by solar weather. Our Sun regularly hurls coronal mass ejections and high-speed streams of charged particles into space. Spacecraft like ACE and SCIVA sit between Earth and the Sun, constantly monitoring those conditions. If a burst from 3I/Atlas follows the arrival of a CME by hours or days, that's a clean, testable trigger.
This mechanism makes intuitive sense.
3I/Atlas has been in near vacuum for eons.
Its surface has never faced an active star's charged particle environment.
When that first wave of solar plasma hits, the comet could respond dramatically, venting ices, cracking crusts, releasing jets, like throwing cold glass into boiling water. But what if the pattern isn't tied to the Sun at all? Another possibility is rotation-locked bursts, the lighthouse model.
Imagine a rotating lawn sprinkler. Each time the jet sweeps past you, you get soaked, then nothing until the next pass. A comet with active vents on its surface would work the same way. As the nucleus spins, different vents face the Sun, releasing jets only when heated.
From Earth, we'd see regular pulses of gas and dust once per rotation. Measure the time between bursts and you've got the rotation period, 12 hours, 3 days, or something else entirely.
Then check if the multi-wavelength fingerprint repeats in phase with that timing.
If it does, you've identified stable vents rotating with the nucleus, a huge insight into the comet's structure.
There's another consequence. Those jets don't just escape, they push back. Newton's third law applies.
Each burst of gas acts like a miniature rocket thruster, slightly altering the comet's trajectory. Astronomers quantify this with 3 non-gravitational parameters A1, A2, and A3, radial, transverse, and normal acceleration. Over months, even subtle jetting can measurably tilt an orbit. We saw something like this with Oumuamua, which showed unexplained acceleration leaving the solar system. 3I/Atlas is different because it clearly shows a coma and gas emission lines. That means we can directly link any trajectory shifts to measurable outgassing, a chance to solve a puzzle we couldn't with Oumuamua.
Most comets are recycled. They've been around the Sun many times. Their outer layers are baked and cracked. But an interstellar comet like 3I/Atlas is a time capsule.
Its ice is formed around another star under different conditions, locked away for billions of years.
When those ices finally meet our Sun's heat and plasma, we're seeing the chemistry of another solar system come alive for the first time. That's priceless scientific data.
It's also why a multi-wavelength burst fingerprint would be so profound.
It wouldn't just tell us about 3I/Atlas, it would tell us about the physics of star systems we'll never visit. We're still in the early days.
These reported bursts are just that, reports.
But the tests are straightforward. Watch the timing. Compare to solar wind data. Check for rotation.
Look across wavelengths.
This is science at its best, open, methodical, skeptical. And you can follow along.
Many observatories publish real-time data.
Amateur astronomers with spectrographs can even monitor some of the optical lines themselves. If you see a spike, note the time. Compare it to solar wind arrival times from ACE. In a way, you can help build the fingerprint too.
Somewhere out there, beyond Jupiter's orbit, a traveler from another star is warming in our sun's light.
We've never seen one behave quite like this before. Maybe the bursts are random. Maybe they're the comet's heartbeat.
Or maybe they're the first signs of a story we've never heard before, a story written across the entire electromagnetic spectrum, waiting for us to read it. Here on this channel, we'll keep tracking every clue, every burst, every signal.
Because the universe doesn't always shout its secrets. Sometimes it whispers.
And if you listen carefully enough, you can hear an ancient comet breathing for the first time in eons. If you love this no-nonsense approach to space mysteries, tap subscribe and hit the bell. It genuinely helps the channel grow, and you'll never miss the next chapter in this unfolding cosmic detective story. Thank you for watching my channel.